Okay, so we are going to simplify expressions today using your product, quotient, and power rules. So first we're going to dissect a term. A term has a bunch of pieces in it. Get the packets on the shelf. You have them. Can you write? Need a pencil? All right, so I've got the vocab words here that we're going to label. Where is the exponent? Yeah, it's the 7. Okay, that's the exponent. All right, what about the coefficient? Which one is the coefficient? Yeah. Which one is the coefficient?
The negative.
The negative 3. Okay, that's the coefficient. All right, the variable is what? Yeah, it's the x. Okay, now this is one you might not know. You might know it. The base is whatever is being raised to the power. So in this case, we want to know, is the base the x or is the base the negative 3x? Yes, you're right. It's just the x. So the base is just the x. Okay, if we had had negative 3x in parentheses raised to the 7th power, then this whole thing would be the base. Do you guys see the difference? Without the parentheses, it's only the x being raised to the power, so only x is the base. Okay. All right. Does anybody know what product is fancy for? What does it tell us to do? Yeah.
Multiply.
Yeah, we're going to multiply. So we're going to try to figure out what we have to do with our powers when we multiply our bases. So we're going to find each of these products by first expanding it and then finding the result. And we're going to look for some patterns in our observations and see if we can figure out a rule so that we don't have to expand it every single time. So these two expanded. If it says x squared, that means I have to write the x twice. It's being multiplied with itself, just written twice. And then if it's cubed, I have to write it 3 times. 1, 2, 3. Okay, so what power of x is that? We've got 1, 2, 3, 4, 5 of them multiplied together, so that's x to the 5th. All right, so you can see it up here, but I'm going to do it on here for everybody else, and then I'm going to erase it. So don't write it down here because you're going to erase it. If I do 5 times 2 times 3, is that equal to 2 times 3 times 5? Well, 5 times 2 is 10, times 3 is 30, and 2 times 3 is 6, times 5 is also 30. So it doesn't matter what order I do the multiplying in, because multiplication is what we call commutative, right? It can commute around. So I'm going to write my 5 times my 3 together. How many times do I write this z? It's just 1, right? Because that's its power. It's not written, but it's hiding there. I have 1z. And then I write 4 more. 1, 2, 3, 4. So 5 times 3 is 15. And what power of z do I have? Yeah, the 5th. Okay, so in all of these situations, what is happening to the coefficients? Up here, we didn't really talk about it, but I had a 1 here and a 1 here. 1 times 1, isn't that 1? So 5 times 3, that's 15. What's happening to the coefficients? What operation? Adding, subtracting, multiplying, or dividing? What? Yeah, multiplying. So we're going to multiply the coefficients. All right. My base was x and my base was x. Did my base change? It didn't turn into w. I just kept it, right? So we're going to keep the base. Okay, and here's the $1 million question. What did we do with the powers? Yeah. Yes. Good. Add the powers. Okay, so we're multiplying same bases. Product is fancy for multiplying. What rule is this? Yeah, it's the product rule. And it says when you're multiplying your same bases, they have to be the same. We get to just add the exponents. So now you don't have to do all that expanding every time. But if you do forget the rule, you can just expand it and figure out what to do. All right, let's look at some examples. All right, so look at the coefficients. I have a -2, a 1 in front of the x, and a 3. And I have to multiply those together. So -2 times 1 times 3, that is a -6. My base, I have to keep. I have x, x, x. So I keep the x, and what do I do with the powers? Yeah, good. Add the powers. Now the only trick is this one right here. What is that power? 1. How tempting was it to say 5 plus 6 is 11? So tempting. Okay, but it's 12. Okay, here I have same bases. So I get to do what with my exponents? Add them. Now, I can't just add a fifth and a half the way they are. I have to change them into same size pieces. Okay, so I know that I have 1/5. Can't I change them both into tenths? Right? So if I multiply my 1 by a 2 and my 5 by a 2, I'm just multiplying by 1, right? So I'm not really changing my fraction. I'm just making an equivalent fraction that I could reduce back into my original fraction. So 1 times 2 is 2. 5 times 2 is 10. 2/5. Sorry, 2/10. My brain. How many tenths is 1/2? Multiply top and bottom by a 5. Yeah. So 2/10 plus 5/10. 7/10. So I keep my base, keep the b, add my powers, and I get 7/10. Now, if you're like, oh my gosh, that's a lot for a Monday, you can delegate that to your calculator. So everybody find a calculator, put brand new bags on them. On your calculator, do this. 1 divided by 5 plus 1 divided by 2. You should get 0.7. And then how do I change that into a fraction, a reduced one? Math. Math, enter, enter?
Yeah, what you said.
Yeah, math, enter, enter. And then you should get 7/10. Okay. All right, next one. We've got same bases. We keep the base, keep the A, add the exponents. 4 plus a negative 2 is a 2. All right, for letter D, do we have all same bases? Do you see we have C's and D's? So we can only add up the C exponents with the C exponents and the D exponents with the D exponents. We can't cross-contaminate. So for C, I have 5 plus 3 will be my power. And for D, what about 4 plus what? What's hiding right there? Oh, I thought it, yeah, I heard it. Okay, 1. So 5 and 3, that's 8. 4 and 1, that's 5. Now, what operation is happening between C to the 8th and D to the 5th? What are all of these here? Are we adding, subtracting, multiplying, or dividing? Multiplying. So don't put a plus in between the C, the 8th, and D to the 5th. We're not adding them. We're multiplying them still. They're just sitting right next to each other being multiplied together. Just like 8 times x, we just write them next to each other, 8x. All right. Quotient is fancy for what? Yell it out. Product was multiplying. Yeah, division. You were thinking of sum. Okay, before we get any further, I want you to add something to a problem. We're changing the problem, okay? Because I meant to put coefficients on these, but I forgot because I was doing too much. So would you please put on here 15 on the top in front of the b to the 9th? And then you guys want a 3 or a 5? 5? All right, let's look at the w's first. Let's expand our first problem. Give yourself some room. Don't write too big because you need a numerator and a denominator. So we've got five w's on the top. 3, 4, 5. Whoa. 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 Okay, and then we got 3 on the bottom. 1, 2, 3. Look at this right here. Do you see how I canceled my 4's? We're going to do the same thing with the w's. These w's can cancel. These w's can cancel. And these w's can cancel. How many do we have left? Yeah, so what power of w is left? Right? W squared is left. W times w. All right. Let's expand. Now this one you have to write small because I gave you way too many b's. I'm sorry. Right? Small. So 15, isn't that 3 times 5? Okay, so we've got a 3 times a 5, and then you got to write 9 b's. This is why you're writing small. 1, 2, 3, 4, 5, 6, 7, 8, 9. Almost didn't fit. Okay, we've got a 5 on the bottom, and only 3 b's multiplied together. So let's look at what cancels. I can cancel my 5s, right? I can cancel B's, B's, and B's. So what's left is a 3, and then keep my base, B, raised to what power? The 6th. So what happened with the 15 and the 5 to get a 3? Yeah, they just got divided. So the coefficients got divided. Coefficients. Oh my gosh. I forgot to say divide coefficients. Divide coefficients. Okay. Did we change the base or keep the base? Yeah. Keep the base. Okay. What do I do to the powers? So I don't have to keep expanding this every time. Yeah, because 5 minus 3 gives us 2. 9 minus 3 gives us 6. So we're going to subtract the powers. Okay, top one was the product rule. What do you think this one is? Quotient rule. This one was the worst for me to spell when I was a kid. It says when we're dividing our same bases, bases, we get to subtract the exponents. So now you don't have to expand every single problem. You only have to expand if you forget the rule. Okay, let's look at some examples. So if I have coefficients right here in the front. So we figured out that we have to divide coefficients. What is a positive 9 divided by a negative 3? Yeah, negative 3. Okay, I keep the base, x. And what do I do with my powers? Subtract them. Isn't that nice? So nice. All right, so far we've been nice and put the big number on top, but it can only last so long. Now, 2 over 8. Isn't 8 just 2 times 4? So I can write 8 as 2 times 4. What happens to my 2's? Yeah, and a 4 is left, but where is the 4? Is it on the top in the numerator, or is it hanging out on the bottom in the denominator? Bottom, denominator. So I've got a 4 on the bottom. What power is on this a in the denominator? 1. So use the quotient rule. 5 minus 1 makes 4 for the a's. So I have a to the 4th. And do I have any powers to combine with that b? No, so he just hangs out. He doesn't move. He doesn't do anything. He's just chilling. All right, we're on a roll. Look at these a's. I have, if it says cubed, I have to write it 3 times. So I have A times A times A over A times A times A. What happens to every single one of them?
They all cancel.
Yeah, bye. If I have the same on the top and the bottom, it just makes a 1, right? 4 over 4, 1. A cubed over A cubed, 1. All right, what about the B's? They're going to cancel. How many are left? 1, because 5 minus 4 is 1. What about the C's? Yeah, I have a C to the first down here, so it ends up being C to the 6th. That's it. All right, this one looks a little crazy because it's got a negative power in it. But the quotient rule says that I have to subtract my powers if I'm dividing. Yep.
Wouldn't it just be z to the first power, negative first power?
Okay, you're warm. Okay, so I'm going to do z, and then I have to say 2 minus a negative 3. What happens when I subtract and do the opposite of negative? What's the opposite of negative? Yeah. So this actually turns into z to the 2 plus 3. Yeah, z to the 5th. That's not so bad. Yeah. All right. We did product, we did quotient. It's time for the power rule. I have the power. Any fans of He-Man?
Yeah.
Yes. Yes. Okay. What do we know is synonymous with power? Starts with an E. What's synonymous with a power? Starts with an E. Yeah, an exponent. Okay, so power to a power is the same as exponent to an exponent. Whoa. Too many syllables. Okay, so when we write these expanded, I want you to give me 2 rows. Okay, so make sure that you don't write in the middle of the box. Give me 2 nice rows. So if it says cubed, that means I have to write x squared 3 times. Okay, so I have to write x squared times x squared times x squared. Now, each of those x squared is x written twice. So this is x times x, this one's x times x, and this one is x times x. So how many x's do we actually have multiplied together? Yeah, 6. So this gives us x to the 6th. Okay, look at the second one. Okay, it's telling me to write 4x to the 4th twice. So I have to write 4x to the 4th times itself, 4x to the 4th. Now I'm doing 4 times 4. And each of those x to the 4th, I have to write x 4 times for each of those. So I've got 1, 2, 3, 4. That's one set. 1, 2, 3, 4. That's another set. So what we're getting is 4 times 4 is 16. Keep the base. Yeah. 8th power, good. All right, so what rules are popping out at you? If I have exponents raised to other exponents, what shortcut do you see that I can use with the powers? Yeah, we multiplied them. So we are going to multiply the powers. Okay, also for this one down here that we did, the second one, everything inside parentheses got squared. So write this down here. We did 4 and squared it, and then we also did x to the 4th and squared it. Do you guys see that? Everything in the parentheses got squared. Yep. Yes, really quick. All right, so this is the power rule. When we're raising an exponent to an exponent, we are going to multiply the exponent. Okay, look at A. So I had, this one's like the one that we just did up here. Okay, so everything in the parentheses is getting squared. The 3 is getting squared, and the x to the 5th is getting squared. What is 3 times 3? Don't say 6. 9. Okay. So what do I do with the 5 and the 2 here? We do what? Multiply. 5 times 2 is 10, and we're done. Okay, it was only a matter of time before I threw a fraction at you. What do we do with these powers if we've got a power raised to a power? Yeah. Kinda. We just multiply them. What you're thinking of is that multiplying by 1/2 is the same as dividing by what? Yeah. So what's half of 4? Well, divide 4 by 2 and you get half of 4. Yeah, z squared. 2. Okay, you can also put that in your calculator. You can do 4 times 1 divided by 2. And then if you get anything weird, decimally, you can just say math, enter, enter. All right, next one. So everything in the parentheses is getting raised to the 4th power. So x squared gets raised to the 4th, and y to the 1/2 is raised to the 4th. So each time I'm multiplying powers. 2 times 4 is 8. We already know what half of 4 is. It's 2. Okay, so everything in these parentheses in part D is also getting raised to the 6th. So I'll have a to the 6th, and I'll have b to what power? 18th. Good. Okay, we're not going to do all of these. We're going to do a couple, and then I'm going to turn you loose and give you back your tests. All right, look at the first one. What operation is happening between all of these terms? All of these factors, I mean. What do these dots mean? Multiply. So is this the product rule, quotient rule, or power rule? Let us finish really quick. Okay, this is important. Product, quotient, or power? Product. Okay, so when I'm doing the product rule, I get to multiply my coefficients. -5 times 4 gives me -20. I keep the base. What do I do to the powers? Add them. So just be really careful because I'm trying to trick you into forgetting this one. What's the hidden power there? Yeah. So 4 and 1 and 5 is 10. Okay, what about this next one? Product, quotient, or power? It's the power. So I just get to multiply all of my powers inside the parentheses by my power of 3 outside the parentheses. So 5 times 3 is 15. What's 1/3 of 3? 1, yeah. Do I have to write that one? Okay. All right, look at these W's. I have 3 W's on the top, and I have 1, 2, 3, 4, 5, 6 on the bottom. Ooh, I need a bigger fraction bar. All right, my W's are canceling. How many does that leave behind? Yes, and where are they? On the bottom. Yes. So I have W cubed on the bottom. Okay, for the x's, 8 minus 4. What's 8? 8 minus 4 is just 4, right? So I have x to the 4th on the top. And for my y's, I have a y on the top and a 1, 2, 3, 4 y's on the bottom. I have y cubed left on the bottom. Which rule was that? I forgot to ask you. It was the quotient. Good. Okay, this next one has 2. What is happening inside parentheses where we can simplify? It's the quotient inside. Okay, what do I do with the 9 and the 3? Okay, so I have b to the 6th. 9 minus 3 is 6. And then what do I do? 6 times 2, which rule is that? Okay, this is power to a power rule. Okay, I don't know that we need to do this bottom row unless you want to do this one with the b's. Anyone want to do the one with the b's? We already did one like it, but we could do another one. Ready to move on? Okay. All right, let's look at example 2 at the bottom. We have to pick all of these that are equivalent to the one they gave us. Z to the 10th raised to the 1/2 power. We have to figure out what that simplifies to before we can figure out which ones are equivalent. So I have a power raised to another power. This is obviously which rule? Yeah, this is the power rule. Okay, so I have to multiply these powers. We already figured out that multiplying by 1/2 is the same as dividing by 2. So what's 10 divided by 2? Yeah, so I have z to the 5th. All right, one of them is already a match. And then z to the 20th obviously is not going to work. What about this one? Yeah, is it a match? Whether I do 10 halves or half of 10, if I'm multiplying, it's the same no matter what order I do my multiplying in. So this is also z to the 5th. All right, what about this one? Z to the 15th over z cubed. You're correct. It is not, because you have to subtract, and 15 minus 3 is 12. So this one is not z to the 5th, it's z to the 12th. Yeah. Okay, so for this one, I'm doing 15 minus 10 because I'm using the quotient rule and subtracting. So this one is z to the 5th. The second to the last one is the product rule, and I have to add my exponents. 2 plus 3 is 5, so this is z to the 5th. And then 8 plus a negative 3 is basically just subtracting, and 8 minus 3 is 5. That's not so bad. All right. Thanks, guys.